Hi, I'm Mr. V, and today we're looking at illustrative mathematics, our text, Unit 1, which the first half is on constructions, the second half is on transformations, and we're looking at Lesson 5, which is Construction Techniques 3, which is constructing the perpendicular bisector and an angle bisector. And by the end of this lesson, you'll be able to say, I can construct a line that is perpendicular to a given line through a point on that line. And you'll be able to construct an angle bisector. So the first question that we have is, given two circles, what do we know about is true about AE and AB? I mean EB and EA. So if we draw these two segments, you're going to notice that these two segments are both radii of circle A and circle B. Circle A and circle B have as a radius segment AB. It's the same for both circles. Since EA is a radius of A, it's the same as EB. Since EB is the radius of circle B, it's the same as AB. So this is an equilateral triangle. These are equal. That's what this is trying to show. And the second thing is true about F. It's the same distance from F, both of these. So these are both the same. Why? Because circle A has as its radius AB. Circle B has as its radius AB. They have the same radii. So any radiuses of circle A are the same as radiuses or radii of circle B. That means that AF, which is a radius of circle A, is the same as AB. BF is the same as AB. And since they're the same, they are all the same. These are equilateral triangles. These 2 points, which is the most important part here, what can we say about these 2 points? What conjectures can we make? This looks like it might be perpendicular. This looks like it might cut this segment into 2 equal parts. This looks like it might be the perpendicular bisector of segment AB. And so these are all conjectures. I conjecture that this might be the perpendicular bisector of segment AB. But I'm going to make a conjecture that any point on this perpendicular bisector is the same distance from A as it is from B. And we're going to test that in a little bit. So when you do this construction, it should look something like this. And you'll have time to do this. You can slow this video down if you want to. I'm going to construct a line that's perpendicular to, let's see, goes through both of these points. And every point on this line is going to be, is going to be the same distance away from A as it is from B. We start with these two that are the distance of AB away from A and B at the same time. But any of these other points would also be. And I can do a drag test. This line is always going to be perpendicular. It's always going to bisect segment AB. This is doing the cutting. This is what is being cut. So in this particular instance, these 2 points happen to be the same distance from this midpoint. But I could have any 2 points on this line and make it into the perpendicular bisector. And this is still what's being cut. It's being bisected. On the next page, we're going to go to a Geogebra Applet, and I will demonstrate it for you here. I also have help videos. If I have a help video for this, I will not demonstrate it. I'm going to try to do whatever I can. So here's a line, the point C on the line. You're supposed to use the straight edge tools up here to construct a line perpendicular to this line that goes through point C. And I do leave you a video of how to do that here. What is important to know is that I need 2 points that are the same distance from C. There's this point, and there's this point. The most common error is for people to draw a circle like what we've done before. When I connect the points here, it's perpendicular to L, but it doesn't go through C. It needs to go through point C. To do that, that means that C will be on the bisector of this segment. And if we make it a perpendicular bisector of this segment, then that line will be perpendicular to L, and it will go through point C. You can watch the video if you need extra help for this particular activity. Here are some instructions. if you want to do it step by step. This next thing is we're going to be bisecting the angle. Ms. Kirkpatrick gives you the instructions. You're supposed to estimate where this orange line cuts this red angle into two equal parts. It bisects it. We've looked at a bisector of a segment. The perpendicular bisector is of a segment. This is going to be an angle bisector. It cuts the red angle. The orange cuts the red angle into two places. And when we look at where other people have put their points, you see they put them kind of in the same area generally. How can we be more precise? How can we actually construct this? So on page 11 is this GIF where you can see and notice different things. And there's some things that you should observe about this. What I'm looking for you to ask yourself is, what do I need to know about this that will help me make the construction myself? And this looks like the perpendicular bisector. In fact, it starts with this point and this circle is the same distance away from that point. I wonder if we do the same thing when we do a construction. So on page 12 is this Geogebra app. Again, I walk you through all of this, and you can watch this video if you need help on how to do this angle construction, angle bisector. Here are the steps for constructing an angle bisector. You should familiarize yourself with them and be able to do them. I mean, do them intuitively, not with having to memorize the steps. Just do them intuitively to know that I have to have 2 points that are the same distance from B. Notice that from these 2 points, B is the same distance from here as it is from here. So if this is a segment, all the points on this line are going to be the same distance from these 2 points. This line, this blue line, will be the perpendicular bisector of this segment. Robert Lang gave us more instructions here, and there's a video you can watch him doing. It is impossible to use construction tools, the compass and the straight edge, to trisect an angle. But if we add origami, where he's doing a fold or two, then all of a sudden it becomes possible. And this is really clever. If you'd like to enhance your learning, you can watch this more. This is the synthesis of this activity, and you'll notice we're supposed to construct a perpendicular line. We're also supposed to construct an angle bisector. And here I have 2 constructions of the angle bisector. The green line is the angle bisector. What's the difference between these two? How did I get these red circles? How did I get these red circles? What did I use for my radius here? What did I use for my radius here? And why does it work? And so you can ask yourself those questions and ponder this a little bit further. Here's the lesson summary. This tells you about the point on a line. We're constructing perpendicular. Notice we had to have 2 extra points. From this angle bisector, from this vertex, we had to have 2 points that are the same distance from this vertex, just like we had to have 2 points that are the same distance from this point that we wanted to go through. For the cool down, you're supposed to order these steps. You can check your answers with this applet here, this little piece of geometry, and then you can tell me where you are today. And that's all I've got. So good luck and success.